math learners. Today, I'm going to discuss composition of functions. The learning objectives are the following. Find the composition of functions and evaluate composite functions. Composition of functions, or known as composite function, is a function that depends on another function. A composite function is created when one function is substituted into another function. The key idea in function composition is, it is an operation that takes two functions and produces another function. And also, the input of the function is not a numerical value. Instead, the input is also another function. Composition of functions, given f and g, which are functions, the composite function f and g is defined as f circle g of x is equal to f of g of x. The first expression is read as f circle g, or f of g. The second expression is read as f circle g of x. And the third expression is read as f of g of x. In computing for f circle g of x, all you have to do is to replace all x in f with g of x. In other words, the right function goes inside the left function. F here is the outer function, and g is the inner function. Notice in f circle g, which is equal to f of g of x, the input or the inner function is function g, because it is to the right of function f, which is the main or the outer function. To elaborate more on this, let us study the given examples. Example 1. Find f circle g of x. Given two functions, f of x is equal to x plus 1 and g of x is equal to 2x. Solutions. F circle g of x can be written as f of g of x, wherein f is our outer function and g is the inner function. So we have to follow the pattern of the function f, that is in x plus 1 form. We have then to replace x by 2x, and the f circle g of x is equal to 2x plus 1, and 2x plus 1 is another function. Example number 2. Find g circle f of x. We have the same given. F of x is equal to x plus 1 and g of x is equal to 2x. Solutions. G circle f of x can be written as g of f of x, wherein g now is our outer function and f of x is the inner function. So by this time, we have to follow the pattern of the given of g of x, which is 2x. Then, we have to change or replace x by x plus 1. Then, simplifying the expression, distribute 2 to x and 2 to 1. So what we have now, g circle f of x is equal to 2x plus 2. Do you have questions? Let's proceed. Example number 3. Find f circle f of x. There is only one given function. You are asked to compose the function by itself. So f of x is equal to x squared minus 3. Solutions. F circle f of x can be written as f of x. And the pattern that we need to follow is x squared minus 3. Then, change x into x squared minus 3. Do not forget the square. And then, the f circle f of x is equal to, we have to simplify first the square of binomial. So, this will mean x squared minus 3 times x squared minus 3. So, x squared times x squared, we have x to the exponent of 4. Or x squared times negative 3 is equal to negative 3x squared. And another x squared times negative 3 is negative 3x squared. And negative 3 times negative 3 is positive 9. And do not forget to write minus 3. The f circle f of x by this time becomes x exponent 4 minus 6x squared plus 6, because we combine negative 3x squared and another negative 3x squared, which is now negative 6x squared. So, the final answer is x to the exponent of 4 minus 6x squared plus 6. Then we have to simplify the expression. Combine negative 3x squared and negative 3x squared, and also positive 9 and negative 3. So the result now is x squared. So the result now is x to the exponent of 4 minus 6x squared plus 6. Example number 4. Find f circle g of x. Given f of x is equal to 3x squared plus 2x and g of x is equal to x minus 1. Solutions. F circle g of x can be written as f of g of x. So by this time, the outer function is f and the inner function is g. We have to follow the pattern of f of x, which is 3x squared plus 2x. Replace x by x minus 1 and the other x by x minus 1. And afterwards, we have to take the square of the binomial. And that is, copy first 3, and we have x squared. X times negative 1 is negative x. X times negative 1 is negative x. And the square of negative 1 is positive 1. And 2 times x minus 1. Then we have to simplify further. What we have now is 3 times the quantity of x squared minus 2x plus 1 plus 2x, distribute 2 to x, and 2 times negative 1 is negative 2. Then, simplify further, we distribute 3 to x squared, 3x squared, 3 times negative 2x, negative 6x, 3 times 1 is positive 3, plus 2x, minus 2. Combine like terms, then f circle g of x is equal to 3x squared minus 4x plus 1. Do you have questions? None? Let's proceed. Let us have example number 5. Find g circle f of x given. F of x is equal to 3x squared plus 2x and g of x is equal to x minus 1. We just interchange the position of f and g in number 4. So, solutions. G circle f of x can be written as g of f of x. So, g is the outer function and f of x by this time is the inner function. We follow the pattern of g of x. The given is x minus 1. So we simply replace x by 3x squared plus 2x minus 1. And then remove the parentheses. Then we will have g circle f of x is equal to 3x squared plus 2x minus 1. Do you have questions? None? Let's proceed. Let us have the evaluation of composite functions. How will you evaluate composite functions? There are two ways. To evaluate composite functions, it's either letter A, once we compose a new function from two existing functions, we evaluate it for any input in its domain. Or you can have letter B, given a formula for a composite function, first, evaluate the inside or the inner function using the input value or variable provided. And number 2, use the resulting output as the input to the outside function. Let us have an example. Example number 1. The solution that I'll be showing you is using option number 1. Evaluate f circle g of 1 given f of x is equal to x plus 1 and g of x is equal to 2x. So the solutions, f circle g of x can be written as f of g of x. Since f is the outer function, then we have to follow x plus 1. Replace x by 2x. So, the result now is 2x plus 1. We will be using the new function and we have to substitute 1 to x. So, f circle g of 1 is equal to 2 times 1 plus 1. And f circle g of 1 is equal to 3. Let's try to find out if we can get the same answer using the second solution. Let us use the same given. So, another solutions. F circle g of 1 can be written as f of g of 1. So, first solution would be we have to evaluate the inner function. G of x is equal to 2x. Substitute now 1 to x. 2 times 1 is equal to 2. So by this time, the value of g of x is equal to 2. The second solution, f of g of x is equal to f of 2. So f of 2 is equal to x plus 1. And x will be changed to 2 plus 1. Therefore, f of 2 is equal to 3. So, circle f of 1 is equal to 3, which is the same as the answer in the first solution. Let us have another example. Evaluate g circle f of 2. Given f of x is equal to 3x squared plus 2x and g of x is equal to x minus 1. Using the first method, we will have this. G circle f of x can be written as g of f of x. So, the outer function is g. We have to follow x minus 1. Replace x by 3x squared plus 2x. And remove the parentheses. Then we will have 3x squared plus 2x minus 1. Afterwards, we're going to use the given value 2. G circle f of 2 is equal to 3 times 2 squared plus 2 times 2 minus 1. So, simplify 3 times 4 plus 4 minus 1. And G circle f of 2 is equal to 15. Let us use the second method. Let's try to find out if the answer is also 15. Let us have the other solutions. G circle f of 2 can be written as g of f of 2. First solution, we have to evaluate the inner function, which is f of x. F of x is equal to 3x squared plus 2x. Then f of 2, since the given value is 2, is equal to 3 times 2 squared plus 2 times 2. F of 2 is equal to 3 times 4 plus 4. And f of 2 is equal to 16. Second solution, g of 16. Because that is g of f of 2. And f of 2 is 16. G of x is x minus 1. So we have to change x by 16. Then minus 1. G of 16 is equal to 15. Therefore, G circle f of 2 is equal to 15. So, we have the same answer as in the first solution. It's up to you what method are you going to use. Anyway, it will give you the same answer. If you would like to choose the first method, then fine. If you would like to choose the second method, it's up to you. Hello, math learners! Today, I'm going to discuss applications of functions. For the Learning Pocket Concept Map, we are now on this part. The last part. The applications of functions. The learning objectives are: you are expected to determine if the given real-life problem represents a function and solve simple problems involving Functions. Application of functions. In most realistic situations, the value of one quantity may depend on the value of another quantity. For example, the cost of mailing a package depends on the weight of the package, and the amount of invested money may depend on the length of time it is invested. In math, such relationships are often represented as functions. Here are some real-life problems involving functions. Example number 1. Cost of mailing a package depends on the weight of the package. So for example, if the weight of the package is 1 kilogram, the cost is 100 pesos. So if the weight is 2 kilograms, it will cost you 200 pesos. And if the weight is 3 kilograms, then the cost is 300 pesos. And we consider this as a function because if we are going to express this in a set of ordered pairs, then we have 100 pesos, 2 kilograms for 200 pesos, and 3 kilograms for 300 pesos. The result shows that if the weight increases, the cost also increases. Second example. An amount of 7,300 is invested for A. 1 year, B. 3 years, at a simple interest of 12% per annum. Find the interest and the maturity value. By the way, annum means year, so per year. For the first solution, we have to use the formula of the simple interest, which is I is equal to PRT. P stands for the principal amount, R for the rate, and T for the time. Let us solve first for the interest. So, all you have to do is to replace 7,300 pesos to P and change 12% into decimal form 0.12 and times 1 for 1 year. So, the result is 876. So, the interest earned for a year is 876 pesos. And to compute for the maturity value, the formula is A is equal to P plus I. A for the maturity value or the total amount is equal to the principal plus the interest. Substitute 7,300 to P and 876 for I, then the total is 8,176. So the maturity value after 1 year is 8,176 pesos. For the next solution, let us solve for the interest for 3 years. 7,300 pesos for P times 0.12 for R and 3 for T. Multiplying 7,300 and 0.12 and 3, so we will have 2,628. So the interest is 2,628 pesos. And for the maturity value, we have A is equal to P plus I. So, 7,300 plus 2,628, the total is 9,928. So, the maturity value after 3 years is 9,928 pesos. So, if we are going to tabulate the interest as well as the maturity value for 1 year, interest is 876 and the maturity value is 8,176. For 3 years, the interest is 2,628 and the maturity value is 9,928. And we consider this as a function because representing in a set of ordered pairs, we have 1 for 1 year and 8,176 for the maturity value. And 3 for 3 years and the maturity value is 9,928. The result shows that if the number of years increases, the interest as well as the maturity value also increases. Let us have example number 3. John wants to collect data on the weight of his kitten as it grows. He decides to construct a table with age in weeks and weight in kilograms as variables. Will the ordered pairs from John's data represent a function or not a function? The answer is, it is a function because the kitten can only have one weight at a given week. Example number 4. John found a relationship in his annual telephone fees and the number of vacations. It seems that the fees generally increase when the number of vacations increases. Which of the following tables below could represent the fees versus number of vacations taken? First one, the fees in Philippine peso, number of vacations. So we have 0 for the number of vacation and you will have 590 pesos. For 1 number of vacation, then 620 pesos. For 2, 650 pesos. For 3, 680 pesos. And 4 for the number of vacation, 710 pesos. For the second table, we have 450 pesos for 0 vacation. For 1 vacation, 520. For 2, 650. For 3, 570. For 4, 630. So, which of the two tables below could represent the fees versus the number of vacations taken? And the answer is table number 1. It shows that the fees increase when the number of vacations increases. Let us have example number 5. The area of a square field depends on its side, S. Find the area of the square field for A, S is 20 meters, and B, S is 50 meters. Will the results of the area represent a function? Let us have the solutions. The formula for the area of a square is A is equal to S squared. If S is 20, then you square 20, that is 400. You square also M. So 400 meters squared. So the area of the square field is 400 meters squared. For our second solution, A is equal to S squared. So the measurement now of the side is 50 meters. You square 50, that is 2,500. And square also meter, then you will have 2,500 meters squared. So the area of the square field is 2,500 m squared. Therefore, the area of the square field, if S is 20 m, is 400 square meters. And the area of the square field, if S is 50 m, is 2,500 square meters. Therefore, this is a function. The result shows that if the measure of the side increases, the value of the area also increases. Do you have questions? Those are examples of real-life situations of functions. Bye!